Today in Algebra 1B, we're going to focus on dealing with operations with radical expressions. In other words, we're going to have some kind of square root, and we're also going to have some kind of an equals piece in here where we're going to have to solve for something. So our job in these is to get the square root by itself so we can get rid of it. So let's take a look at kind of our first few examples here. So first of all, just like I said up here, solving equations with square roots requires getting a variable by itself, just like you normally would, and then squaring to get rid of the square root. So in this one, you can see the square root is over the x. So if I was to add 3 to both sides, square root of x is going to equal 7. And then, just like we've dealt with before, in order to get rid of the square root, I'm going to square both sides. What happens then, the squaring and the square root cancel each other out. And I'll be left with just an x there. And then 7 squared would be 49. Now, if I really wanted to make sure this works, I should be able to go back and put 49 in here and this should work. So the square root of 49 is 7. So 7 minus 3 does equal 4 and it checks out. But I should be able to plug that back in and check my answer, somewhat like we did with the quadratic stuff that we were dealing with in Chapter 10. Okay, let's look at another example. Okay, in this one, these are a little different because, first of all, this square root is already all by itself. And this one's a little different because there happens to be 2 square roots. So on this one, since the square root's already by itself, I'm going to start by squaring both sides. So when I square this, the square and the square root cancel each other out, so I'm left with x minus 3. 4 squared would be 16. If I add 3, I get x equals 19. Now if that's true, I should be able to go back up here and put 19 in here and it should work. So 19 minus 3 is 16. The square root of 16 is 4, so that works. I have to be able to check them to make sure they work. Now in this one, because the square roots are already by themselves, each on either side of the square root, or equal, I'm going to square both sides. So squaring and the square root will cancel each other out. So this just becomes 3n minus 2, and this becomes n plus 6. And I'm going to add a 1 in front of this just to make it easier to solve. So I'm going to subtract 1n from both sides. So 2n minus 2 equals 6. Then I'm going to add 2. Oops. Let's try that again. Add 2. So 2n equals 8. Then divide it by 2. And I get n equals 4. Now if that's really going to work, I should be able to put it in up here where the n's were at, and it should work. So 4 plus 6 is 10, so square root of 10. On this one, 3 times 4 is 12, minus 2 would be 10. So square root of 10 on both sides equals each other. Okay, now, on this kind of a problem, if I want to solve this, remember I've got to get the square root by itself. So add 5 to both sides. So I have the square root of x equals 9. Then square both sides. And I get 81. Now if that were true, I should be able to go back in here and check it. So the square root of 81 is 9, so 9 minus 5 does equal 4, and it checks out. Okay, last one. So on this one, I have my square root all by itself already, so I'm going to square both sides. So then this is just x minus 5, and this would be 16. Add 5. and I should be able to plug it back in. So 21 minus 5 would be 16, and the square root of 16 does equal 4, so it checks out.